Okay, so we're going through some more explanations under our moles/stoichiometry questions. Let's take a look at number 5 here. Alright, so you see that you have a whole reading passage here and some information. When you're doing part 2 questions, there's always this line that kind of gives you the grouping of questions that go along with the reading passage on part 2. I call it part 2, the second section, short answer section of the test. So don't blow that off. Make sure you realize that you need to use that information at times to answer questions. So what I've done is I crossed out other questions here that go along with the reading passage that are in other topics, and we're going to focus our attention here on determining the number of moles of copper in the bracelet, because it's under moles/stoichiometry. So let's take a look. So we need to determine the number of moles of copper, and I know for moles there's going to be an equation associated with it. Now, if I go and take a look at the reference table that has the formulas, there's 2 places where the word moles shows up, here under mole calculations and here with molarity. So it really depends now on the information that's given in the problem. So let's go back, and I'm told in the reading passage here that the copper bracelet has a mass of 30.1 grams, so that's my mass. And based on given the mass, and I don't see anything here about molarity or liters, I'm going to end up using the first equation here to answer the question. So I'm looking for moles, I'm given the mass and the gram formula mass. Of course, I can look that up. I need the gram formula mass for copper, which is going to be the bigger number here, and I'm going to go ahead and plug in. So the other thing, I've mentioned this before, use a calculator. The other thing you want to do is write down the equation, moles is equal to mass over gram formula mass. So you're plugging everything in properly and not going to make a silly mistake. So I have 30.1 grams, and I'm just determining, so I don't have to show anything, divided by 63.5 grams per mole, and I'm going to end up with an answer of I put it down as 0.47 moles. It didn't say anything about sig figs, so you could go out a couple of decimal places, you could round it to 0.5, and you'd be fine. Okay, let's check out number 6. So number 6 goes along here with this reading passage about urea, and the first question here says determine the gram formula mass of the product. We've seen a question like this before on the last video, where we're looking at a structure here, and we have to list all of the elements, the number of times they appear in the formula, get the masses off the periodic table, multiply them out, and add them up. Again, do this on paper as you're going through. Let me just erase some of the information here from the last question so we have a little bit of room here on the side to get rocking and rolling. Alrighty. So let's go back. Okay, so what do I have? I have nitrogen. It looks like I got carbon, I got some hydrogens, and an oxygen. So I count them up. I got 2, I got 1 carbon, I got 4 hydrogens, 1 oxygen. Now I need to multiply them by the gram formula masses on the periodic table. I come back. I'm not dealing with copper anymore. I'm going to do it in red, right? I got hydrogen, I had carbon, oxygen, nitrogen. Okay. So 14, we got 12, we got 1, 16. We're going to multiply them out. And then, of course, add them up. We add them up, and the answer is 60. Now, please, write everything out. Don't skip steps. Then go ahead and multiply and then add them up. Practice the way that you want to do it on the test. If you start shortcutting, you're going to make a silly mistake on the test. You don't want to do that. All right, let's take a look at number 7. We're looking for the empirical formula of the product. Well, let's write the molecular formula that's here. And we have a carbon. I'm just going ahead and taking this and just kind of condensing it here, getting rid of the bonds, the lines. I have 1 carbon, I have 2 nitrogens, I have an oxygen, and I have 4 hydrogens. It doesn't matter what order you put it in for the test, and if I want to write an empirical formula, it's the lowest whole number ratio. And guess what? Since I have 1 carbon and 1 oxygen, I can't divide anything through and not end up with a fraction or decimal. So guess what? My empirical formula is also the molecular formula. All right. And then finally for question 8, it says explain why this balance equation represents conservation of atoms. Well, when you balance equations, the number of atoms of the different elements you start with, you have to end with. So all it is the bonding gets rearranged. So you just have to say something like that, right? The atoms of different elements you start with, you end with. The bonding is just different. Again, my suggestion is listen to what I have to say, write it down, so that this way, of course, you have it if it's asked again on another test. Let's check out more questions with part 3 of mole/stoichiometry.